In this lesson, we are going to introduce you to the different forms of energy. So these are learner's outcome. We'll be showing you the different forms of energy, and we'll specifically go into kinetic energy and gravitational potential energy formulas. Energy is defined as capacity or ability to do work. The SI unit is in joules or J. Okay, remember that work done is force times distance moved in the direction of force. So a simple way to visualize an object having energy is that it can exert a force. So there are many different forms of energy that an object can possess. So these are some of the different forms of energy. Kinetic. Kinetic is actually very simple. It's just simply that the energy that a moving object possesses. So as you can see from a billiard example, if you hit another billiard ball, it will cause it to move. Sound energy is actually a form of kinetic energy. So as you hear from a speaker, the sound coming out from a speaker can actually influence the flame to get extinguished. Then thermal energy is commonly known as heat energy. Thermal energy is illustrated by the diagram. It excites the air molecules that surround it and causing it to move more and more faster. Electrical energy. You find that electrical energy is actually a movement of electrons caused by a battery. So this is electrical energy is the movement of electrons. Light energy is able to knock off electrons and then enabling it to produce an electrical current or electrical energy. Okay, there's also potential energy, commonly known as stored energy. So there are several types of potential energy as illustrated here. Elastic potential energy is a form of potential energy that is stored as a result of deformation of some elastic object. So for example, spring. Okay, we shall use a simulation to see what do you mean by elastic potential energy. So as you see from this simulation, there's a spring, and if you cause it to stretch, and potential means that even if you seemingly doesn't have any energy, but at this stretching you find that it's actually able to move. Okay, or you can compress the spring, and even though currently it doesn't do anything, but once you release the spring, it will actually have a movement and so on. Next, gravitational potential energy. So it's a form of potential energy that the object possesses due to its position in gravitational field. So again, we use simulation. You find that gravitational potential energy is simply just energy that object possesses by being off the ground. So even though the object is not moving now, but once you drop it off, okay, it will actually move. Okay, and of course the higher it is, you find that it actually drops faster. Okay, it is somewhat similar to a spring. Okay, if you put in this direction and you pull it up, the higher that you pull it up, the more energy that it is actually storing. Okay, somewhat similar like that. Next, chemical potential energy, a form of potential energy that is absorbed or released during chemical reactions. So if some of our chemicals are kept separate, they will not react. If you place them with one another, they will actually form a very explosive reaction, such as the following. Okay, next, nuclear potential energy is a form of potential energy that binds the protons and neutrons in the nucleus of an atom together. Okay, one example of this nuclear potential energy is released from the sun when hydrogen is changed to helium under a very high temperature. This is known as nuclear fusion. Okay, we'll talk about more extensively on kinetic energy. So kinetic energy is the energy possessed by a body due to its motion. In other words, a moving object will always contain kinetic energy. And the formula for kinetic energy is half mv squared, where m is the mass of the object and v is the velocity of the object. This formula describes the feature that determines the amount of kinetic energy an object has. assuming that two objects have same mass but have different velocities. A ball, for example, a ball that hits you at 1 meter per second compared to 5 meters per second. So which situation would hurt more? A ball that hits you with 5 meters per second would hurt more than 1 meter per second. So actually describe that the object has a higher velocity would have a higher kinetic energy. So what about 5 meters versus negative 10 meters per second? Okay, so a negative velocity does not mean that it is actually slower. The negative sign actually indicates the direction of the object. So the direction of velocity does not matter. It is actually the magnitude that matters. Okay, so in this case, the greater magnitude of the velocity would mean that it is greater amount of kinetic energy. Okay, and if you look at the formula, you realize that this square. So having 5 square and having a negative 10 square, you find that actually having a negative 10 square would actually means that it is of a larger value. Do take note that if you increase the velocity of the object by twice, the kinetic energy of the object not only increase by twice. Actually, in fact, the KE of the object would be 4 times of the original KE. Okay, again, it is because of the formula. So assume that an object of a mass of 2 kg. This is the table of velocity versus kinetic energy. So look carefully. So if the velocity is 1, you find that kinetic energy in this case is just applying the formula is 1. But if the velocity is 2, you find that based on the formula, the kinetic energy will be 4. 3 will be 9, 4 will be 16, 5 will be 25. Similarly, if you have two objects that have same velocity but different mass. So imagine that you have a heavy truck and a light bicycle traveling at the same velocity. Okay, but obviously you will try to avoid the heavy truck versus the light bicycle. Okay, because the heavy truck will do a greater damage when they knock into a wall. So that's to try to illustrate that the object that has a higher mass would have a higher kinetic energy. But it doesn't mean that an object with a small mass will not have a high kinetic energy. In fact, a small object that has a very high velocity would actually have a lot of kinetic energy. Okay, because kinetic energy depends on two factors, mass and velocity. So for this example of a speeding bullet will cause a lot of damage. So next we'll move on to gravitational potential energy, or GPE. Is the potential energy that an object possesses due to its position in its gravitational field. It sounds complex, but for now we will keep it simple. Okay, and the position that we'll talk about is usually in reference to the ground level. In other words, it means that it is the height above the ground. So the formula for gravitational potential energy is mgh, where m is the mass of the object, g is the gravitational strength, and h is the height above the ground of the object. For situation that's near the surface of Earth, g is simply just 9.81. So looking at the formula, a simple way of visualizing the amount of GPE is simply how high the object is above ground. Okay, so you find that if you have two objects, one similar object, one object that is higher and one object that is lower above the ground, the higher the object, the more gravitational potential energy. As it drops, you find that this object will actually cause more damage. But however, if the object have the same height, okay, if the object has same height, you find that a larger object will actually has more gravitational potential energy, as illustrated by this formula. So mass and height are factors that actually determine the gravitational potential energy. So that's all for now. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysicsteacherswordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.